Average power, I have completed AC circuit with what? I have completed with resistance only.
Yes, ma'am.
Yes. So what you have concluded in AC circuit containing resistance only, what you have concluded? See, my screen is visible to all of you.
Yes, ma'am. Visible, ma'am.
Okay. So AC with resistance only, what you have concluded, tell me. Yes, tell.
We have learned about, ma'am, instantaneous power. That.
Yes, you have what you have concluded, tell me. AC circuit with resistance
Ma'am,
only
ma'am, the applied current and voltage are in phase
in
with each
phase.
other.
Yes, in phase with each other.
Yes, ma'am.
That means phase difference is zero.
Zero,
And what
ma'am.
is the power consumption?
Ma'am,
What is the power consumption?
I, ma'am,
Yes,
it
raise
is
the answer. So many students
Ma'am,
are
I
there.
square into R.
Very good. It is equal to I square into R, and there is no phase difference between what? No
I mean,
phase difference between what? V and
I
I.
am. Yeah.
Okay.
Yes, ma'am.
There is now come to the next one, that is AC with AC circuit with inductance only. AC circuit with inductance only. When you are writing AC circuit with inductance only means this is a pure inductor. Listen, all of you. This is a basic difference. AC circuit with pure inductance only implies that only inductance implies there is no resistance. In the circuit, you will not connect any resistance. Pure inductor. Okay, you will use a what? Pure inductor. There is no resistance at all. This is an inductor, and we will connect a AC supply to an inductor. So what will happen? Tell me. So this is instantaneous voltage, that is equal to Vm sine omega t. Okay. So this is your which voltage? Small letter. I have told you which voltage it is. It is which voltage? Tell me. And
Ma'am,
this is
instantaneous voltage.
instantaneous voltage.
Instantaneous.
Now this is your instantaneous current. Okay. Now the voltage across the inductor will let it be VL. Okay. So I can write down V is equal to, in mathematical form, V is equal to Vm sin omega t. Okay. Now one thing, remember that due to the inductor, when we are providing an AC voltage, okay, when I am providing an AC voltage and AC current is flowing, due to the presence of the inductor, what will happen? Tell me. An inductor is there, you are giving an AC voltage, AC current is going inside the inductor. So what will happen? Tell me. Hmm.
रिवर्स EMF चलता
Yes.
रहेगा
And
continuously.
EMF will be induced. Very good. Who answered? Who
Amish.
answered? Amish, very good. So, an EMF will be induced. So, here you write down one point. When an alternating current flows through a pure inductive coil, okay. So, this will be equal to a back EMF, that is equal to L di by dt. This is induced. Okay. This is induced due to why? Why the EMF is induced? Due to the presence of inductance. Due to inductance in the circuit. Okay. Due to the inductance of the coil. So this back EMF what we call it as back EMF, opposes at every instant, it will oppose the cause that produces it. So the cause producing this EMF is the voltage. So at every instant, this back EMF will oppose the voltage. Okay, got it, all of you?
Yes,
Okay, yes. So here we can write down V is equal to, again I'm writing V is equal to Vm sine omega t. So this one, so this will be equal to Vm sine omega t. So here what will happen to your VL? VL is equal to how much? Just now I have told you there will be an voltage, EMF will be induced in it, that will be equal to L di by dt. So can I write down V is equal to Vm sine omega t, that is equal to L di by dt. Am I clear up to this, or any is
Yes,
there any
ma'am.
confusion? No confusion?
मैम नेगेटिव नहीं होगा क्या वो?
Negative is for here when you are writing a negative here, this back EMF. This is for, this implies that it is opposing the cause that produces it. Okay, it is opposing. Minus is for only opposing the cause that produces it. Clear?
यस मैम, तो फॉर्मूला में हम लोग का नेगेटिव नहीं होना चाहिए क्या? ये वी एम साइन ओमेगा टी इक्वल टू माइनस एल टी आई बाई डी टी.
Minus, so listen. V is equal to minus L di by dt has no relation with the magnitude. I am writing the magnitude part.
ओके 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 मैम.
Okay, clear?
यस मैम.
So yes. So
Ma'am.
here, हाँ बोलो.
मैम ये लेंज लॉ एक बार फिर से बता दें. लेंज लॉ
Lenz law tells that when there is an EMF, which is say, when there is a, according to your Faraday's first law, what is your Faraday's first law? When you are applying some voltage and the current is an alternating current, so there is a rate of change of current, right? So due to the rate of change of current, and EMF will be induced here. Okay, according to the value of the inductance, due to the rate of change of current, a voltage will be induced. These voltage we call it as what? Which voltage? It is called as back EMF. Why it is called as back EMF? Because according to the Lenz law, when there is a Faraday's law tells that an EMF will be induced. Lenz law tells us when there is an induced EMF, it will oppose the cause that produces it. Which is the cause producing the EMF? Which is the cause producing the EMF? This voltage? Yes or no?
Yes, ma'am.
Who was asking?
Ma'am, suppressor.
Yes. So here, this voltage is the cause that has produced which one? This EMF. So at every instant, this back EMF will oppose the supply voltage. Understood?
Yes, ma'am.
At every instant, the back EMF will oppose the supply voltage because the cause producing the back EMF is the supply voltage only. Understood?
Yes, ma'am.
So that is your Lenz law. So V is equal to Vm, that is Vm sin omega t, that is equal to L by d by dt. So here what we do it is, again I am clearing you, here we are putting a minus sign. This has no relationship with the magnitude. Understood? Who was asking? Suprashad.
Yes, ma'am.
Another. No relation with magnitude. This implies that this is opposing the cause produces it. Okay. So V is equal to Vm sin omega t, that is equal to L di by dt. So from this equation, I am getting di is equal to Vm divided by L sin omega t dt. Am I clear to all of you? So now we will integrating, what we will get? Integration of di will be equal to I, that will be Vm divided by L, this is constant, integration of sin omega t dt. Clear to all of you? Is there any doubt up to this? Tell me. Any doubt?
No, ma'am.
Okay. So this will be equal to integration of sin omega t dt will be equal to Vm divided by omega L minus cos omega t. Okay. So this implies I is equal to Vm by omega L minus cos omega t. We can write down sine omega t minus pi by 2. Clear to all of you? Okay. So now this is my equation. This is my equation. I will be equal to, I is equal to Vm divided by omega L sine omega t minus pi by 2. Now when I will get the maximum of this I is maximum when? When sine omega t minus pi by 2 will be equal to how much? 1. Maximum value of sine is what? 1.
1.
So this equal to, this implies I will be equal to Vm divided by omega L, that we call it as the maximum value of I. Clear to all of you? So this implies Vm by Im, that is your I maximum, that we call it as Im. Okay, Vm by Im is equal to how much? Omega L. Clear to all of you? So from here, we can write down this equation as I is equal to Vm by omega L is your Im sine omega t minus pi by 2. Any doubt? Anybody if you are having, stop me and ask question. All of you got it?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Written all of you? So now what was your voltage equation? Tell me. What was your voltage equation? V was equal to how much? Vm sine omega t. Yes or no? What is your current equation? Instantaneous current. Instantaneous voltage was Vm sine omega t. Instantaneous current was Im sine how much? Omega
Omega t
t
minus pi by 2.
minus pi by
Minus
2.
pi by 2.
Very good. So what you conclude from these two equations? Tell me, from instantaneous voltage and instantaneous current. What
There
you
is a phase
conclude?
difference in the
Very good.
क्या बोलते हैं इसको? Voltage and current.
And current. So from here, we can get a conclusion that, take it as a note. What is your conclusion? In an AC circuit with pure, because when you are taking different circuit elements, the phase angle between, or the phase difference between the applied voltage and current will change according to the elements which you are using. Like your resistor, it will be different than an inductor, then or inductor resistor, it will be different, then capacitor, it will be different. According to the circuit elements, there will be variation in the phase difference between the voltage and current, right? So in an AC circuit with pure, what we have taken? We have taken pure inductance. Okay, pure inductance only. In an AC circuit with pure inductance only, the phase angle or the phase difference between, or we can write down, insert, the voltage leads the current, or we can tell the current lags the voltage by an angle of, what? Tell me.
Pi by 2.
Exactly pi by 2 radians, or how much degree? Or 90
90
degree.
degree.
Okay, this is a very important point. Pi by 2 Bhavya, Priyadarshini, you understood?
Yes, I'm understood.
Very good. So pi by 2 radians or 90 degree. So now if we will draw the graph, of the voltage and current, your voltage I am taking as the reference Vm sin omega t. This is my reference waveform. This is your voltage is equal to Vm sin omega t. where Vm is the maximum value of the voltage. Okay, how will be the current waveform? Tell me. Current, where the zero point of reference of the current waveform will start? Tell me. Yes, tell. Where the zero point of reference of the current waveform will start? What is my equation? V is equal to Vm sine omega t. I equal to how much? Im sine how much? Tell me. Omega t minus pi by 2. So from where the zero reference of the current waveform will start? Yes, tell.
वो 1 से मैम
Hmm?
मैम वो पीक वैल्यू 1 से फिर नीचे जाएगा
1 से इधर
नहीं नहीं मैम जहाँ पे ओरिजिन वाली लाइन है वाई एक्सिस से
Ma'am,
y
minus pi
axis
by 2.
minus
Minus
pi
pi
by
by
2. Yes, tell me. Where we will start? I have told you in the phase difference lagging, in which case you will take lagging, in which case you will take leading.
मैम
मैम ये पाई बाय 2 फिर पीछे है ना
एग्जांपल लिखो बीट
Pi by 2 से start होगा इधर से.
यस मैम
From here it will start.
यस मैम
हाँ yes sir.
No, ma'am. No, ma'am.
minus pi by 2.
पीछे
हाँ minus pi by 2. देखो just see yesterday or last class I have discussed you. Look at your copy. Look at your copy and tell me where I will start, where the zero waveform, in which case I have told you that there will be leading and in which case there will be lagging. Yes, so many students are there not able to.
माइनस में मैम राइट साइड से स्टार्ट होगा मैम मिड से मैम
किसने बोल रहा है? सत्यव्रत.
यस मैम
I expect some answer from the girls. Sir,
Left
girls
side,
are
ma'am.
not attending the class or what?
मैम जहाँ पर आपने कहा है
राइट से स्टार्ट होगा
कहाँ पर मैं अपने लगाई हूँ? यहाँ
मैम
पर भी लगाई.
जहाँ पे आपने मार्क किया था वहीं से नो मैम राइट साइड राइट साइड
राइट, यहाँ से.
राइट वाले के मिड हां मैम
अरे तुम लोग इतने जल्दी आंसर बोल रहे हो ना.
मैम मैं स्टार्टिंग में
So
बोल
quickly आंसर बोल रहे हो तुम लोग. Here it will start. I have told you in which case it
Yes,
will be lagging, in which case here the current is lagging.
पॉजिटिव होता तो लीडिंग होता मैम नेगेटिव माइनस पाई बाय 2
Minus pi by 2 implies that it is lagging. Current is lagging. Lagging implies, always remember, lag means 0 point will start later. Lag means 0 point of reference will start later. Understood? That I have told you to how to remember. हाँ? ऑनलाइन में रो है वो पढ़ोगे नहीं कैसे होगा? So the here 0 point will start after how much radians? After Everyone tell resistance. Yes or no? Voltage by current what? You will tell resistance. Don't always speak resistance. Okay. Voltage by current is always an opposition to the flow of current. Here, the opposition to the flow of current by an inductor, we call it as inductive reactance. Okay. Inductive reactance, that is equal to how much? XL. That is defined as XL. So, in an AC circuit, don't always use a term resistance. Somebody will, many of the times I asked students, voltage by current ratio in the, here you will take, here we are providing voltage, here the current is there, voltage by current, immediately answer comes resistance. Okay, resistance is there in case of DC circuit, but when you are coming to an AC circuit, you are using inductors, you are using capacitors, you are using combination of different circuit element. Okay, so I will tell you later on what is the voltage and current ratio. Here in an AC circuit with pure inductance only, voltage by current ratio, we call it as inductive reactance. It is defined as, here I am writing the definition of inductive reactance. The opposition to the flow of current, always the opposition to the flow of current is defined as the ratio of voltage to current. Okay, opposition to the flow of current by an inductor is called as inductive reactance. Understood all of you? All of you got it?
Yes, ma'am.
Inductive reactance. Okay. So, okay, very good. So now inductive reactance formula is what? XL is equal to 2 pi FL. If I am taking the frequency equal to 0, no frequency, okay, there is no number of cycles per second is 0, no cycles. That is in case of a DC where you are having a constant magnitude, there is no cycle. Okay, so frequency is 0 means what is the inductive reactance? Inductive reactance is also 0. Got it or not? So, inductive reactance is 0 implies what? When frequency is 0, inductive reactance is 0. What I have defined inductive reactance? Inductive reactance is the opposition to the flow of current by an inductor. So, when inductive reactance is 0 means what? There is no opposition to the flow of current. Right? Got it or not? When inductive reactance is 0, there is no opposition to the flow of current. That means when the frequency is 0, inductor does not oppose the flow of current. That means what? Inductor behave as a what? Inductive reactance is 0 means what? Inductor behave as a pure conductor. When you are providing a DC supply, you take an inductor and you give some DC voltage. Okay, it will act as a pure conductor. That means it will act as a short circuit, which we have already discussed in case of a DC transient with inductor. Yes or no? Got it or not? Understood all of you? Or again I will tell you. Understood?
नहीं, इसको थोड़ा और एक बार रिपीट कर दीजिए.
मुझे बोलना है हर समय. हाँ. So when we are taking frequency equal to 0, what happens to your XL? XL equal to 0. That means there is no opposition to the flow of current. Okay, there is no opposition to the flow of current. That means if the inductor acts as an pure conductor. Inductors acts as a conductor. Understood?
Yes, ma'am.
It will act as a short circuit. There is no opposition to the flow of current. Clear? So when you will use an inductor and provide a DC supply, this I am talking about a DC where your frequency is 0 means in case of DC. These are fundamental, basic things. Got it? Now, was asking.
Yes, ma'am.
Yes, ma'am. Got it.
Very good. So now here, if I will draw, now as I am increasing the frequency, as frequency increases, what happens to the inductive reactance? Inductive reactance will also increase. So if you draw the graph between frequency versus inductive reactance, as you are the current graph, yes, it is the graph starts from origin and it is a linear graph. Okay, understood all of you?
Yes, ma'am.
Written all of you? Girls, all of you got it? Bhavya, Ritika,
Yes, ma'am. Yes, ma'am.
Krishna, Chabi. Okay. Now come to instantaneous. All of you have written? Written all of you?
Second one, just.
Okay, right.
मैम वो इंडक्टर के बगल में क्या मैम थोड़ा राइट करिए मैम
क्या हुआ?
मैम थोड़ा राइट नीचे मैम
This one?
यस मैम
Written?
यस मैम
Okay. So now come to instantaneous power. Instantaneous power. I have told you how you are finding out instantaneous power. Instantaneous power is denoted as small letter. All small letter represents instantaneous value. Okay. Small v, small I, all are instantaneous value. That depends upon the time. Okay, that is instantaneous value at particular instant. So instantaneous power is equal to the product of instantaneous voltage into instantaneous current, right? So what was the formula for the instantaneous voltage? V was equal to how much? Vm sin omega t. What was the value of the instantaneous current? I was equal to how much? Im sin
Omega t minus pi by 2.
very good, omega t minus pi by 2. So this is equal to Vm Im sin omega t multiply with sin omega t minus pi by 2. Okay. So if we will integrate, so this will be equal to sin omega t minus pi by 2 is equal to minus cos omega t. Vm Im sin omega t cos omega t minus cos omega t. Okay. So now if I will find out the average value, this is the instantaneous power. If I will find out the average value, how I will find out the average value? I will integrate this one over one complete cycle. 1 by 2 pi. Average value is what? Area divided by base. Base is my 2 pi because I am integrating over one complete cycle p dt. Right? Any confusion with this? Tell me. Is there any confusion?
No,
Is there any confusion? Tell me.
नो मैम
So
No.
if we will find out, very good. If we will find out the average value, this you will get it as what you know? 0.
M0.
Okay. This you will get it as 0. So here you are getting a very, very important conclusion that average power consumed by a pure inductor is 0. Pure inductor is 0. Okay, this is a very important. So that is the reason. But what was the average power consumed by resistor? You remember? What was the average power consumed by resistor? Tell me. It was equal.
I square.
Very good. You have remembered so much. So here you see that is the reason why inductor is called as an energy storage element. But resistor, only energy will be dissipated. But you take a pure inductor, listen to me all of you. You take a pure inductor, you give some voltage, you will see that it does not consume any power. That means the power consumption is completely 0 if you are taking a pure inductor. That is the reason why inductor we call it as energy storage element. You give the power, it will store it. But you give the power to a resistor, there will be power loss in the form of heat.
8.
Okay, but if you give a power or give you energy or give supply to an inductor, it will store it. Understood? It will store it. After that, it will return back to the whatever the supply or whatever the power it has consumed from the source. It will again return back to the source. Okay, there will be no loss in the power at all if you are taking a pure inductor. Am I clear to all of you? All of you understood or not? Tell me.
Yes, ma'am.
Yes, ma'am.
Okay, if you take a pure inductor, the average power consumption is completely zero. That is the reason you may get question. Why inductors are called, why inductors are energy storage element? Your answer should be they are energy storage element because the average power consumed by a pure inductor is completely zero. If you give, if it takes power from the source, after that it receives that power to the it gives back that power to the source again. Okay, so here you see, let us see that one written, all of you. So now here you see I will draw the waveform which I've already drawn it. No need to draw it again, you can do it in the same waveform. This is my voltage current waveform. Start at what? Tell me, after pi by 2. Yes or no? This was my current waveform. Now let us draw the instantaneous power. This is my voltage, this one is my current waveform. So instantaneous power will be the product of voltage and current. Here current is negative, voltage is positive. So instantaneous power will be negative. Understood all of you? Look at my graph and then you draw, otherwise you will confuse. See, from this point, from pi by 2 to pi, from pi by 2 to pi, both voltage and current are positive. So power will be positive, right? Got it, all of you? Now from pi to 3 pi by 2, this is 3 pi by 2. One is negative, one is positive. So power will be what? Negative. Understood? All of you got it? Or again I will tell you. All of you understood or not?
Yes, ma'am.
Yes, ma'am.
Now here both are negative. So power will be what? Power will be positive. Okay. So here you see the waveform. Here you see the waveform. What will be the average value of this one? What is the average value of this one? Average will be equal to 0. Okay. You see here the power, it is, you are giving the power to from the inductor is receiving the power from the source during this period. In the next period, the inductor is giving that power to the source again. Okay, so there is a fluctuation in the power, there is a to and fro motion of the power that I will discuss later on. So just here at this instant you make it clear that the power consumption, average power consumption of a pure inductor is 0. Clear to all of you? Understood?
Yes, ma'am.
Yes, ma'am.
Okay. So now we will go for AC circuit containing capacitance only. AC circuit containing pure capacitor only. Pure I am writing because there is no resistor in the circuit. Pure implies there is no resistance in the circuit. Okay, but practically you will never get a capacitor or never get an inductor in the pure form. Some power will be lost. Okay,
मैम इसमें भी 0 होगा.
इसमें भी 0 होगा. कैपेसिटर भी तुम्हारा एनर्जी स्टोरेज एलिमेंट है, यहाँ पर
Yes,
भी
ma'am.
0 होगा. Okay, good. So let us see that one. You take a capacitor, this one I have to complete. Take a capacitor and we will provide an AC supply. Okay, so this is your V, that is equal to Vm sine what? Omega t. This is your current waveform. This is my capacitor. Voltage across the capacitor is your Vc. Okay. So here Now, what will happen when you are providing an alternating voltage to a capacitor? Then what happens? V is equal to how much? Vm sine omega t. Yes or no?
Yes,
Okay. So charge will be accumulated here when you are providing the supply voltage. Charge will be accumulated here, right? So what will be the charge on the capacitor? Charge on capacitor will be equal to Q, small q. That will be equal to how much? C into, oh sorry, it will be equal to how much? C into V, or this is equal to how much? Q is equal to C into Vm, how much? Sine omega t, right? Clear to all of you, or any doubt? So
Yes.
here, I will be equal to, I is equal to how much? Rate of flow of charge, I is equal to dq by dt. So if you do the differentiation of C Vm sine omega t with respect to t, so this will be equal to, differentiation will be equal to, differentiation of sine omega t is C Vm is constant, omega cos omega t, right? Am I wrong? Have I done anywhere wrong? Check it. Correct है तो? Is it correct? Okay. So this implies I is equal to how much? I is equal to C, oh sorry, CVm omega cos omega t. Okay, so this one I can write down as CVm omega cos omega t. I can write down as sine how much? Omega t plus pi by 2. So how I will get the maximum of this one? I will get I is maximum when? When sine omega t
Equal to 1.
plus pi by 2. Sine omega t plus pi by 2 is equal to 1.
1.
Okay. So I is equal to I maximum, that is equal to how much? C Vm into omega. All of you are writing or not?
Yes, ma'am.
Okay. So from here, I can, from here, this implies your Im divided by Vm divided by Im will be equal to how much? 1 by omega c, or this is equal to 1 by 2 pi fc. So here I will introduce another term called as capacitive reactance. Capacitive reactance, it is denoted as capital X with subscript C. Okay. So this Vm divided by Im, Vm divided by Im, this is equal to V divided by I, that we call it as, that is equal to 1 by omega c, or that is equal to 1 by 2 pi fc, that is we call it as xc. This is called as capacitive reactance. Okay. So capacitive, in capacitive reactance, if when F is equal to 0, X is equal to how much? Infinite. Okay. So F increases, what happens to Xc?
Decreases.
Decreases. So if we'll draw the graph between F and Xc, okay, the graph will be like this. So at DC supply here, this is in case of when F is equal to 0 implies this is in DC case. Okay, so at that time Xc is equal to infinite. That means what? Xc is what? Capacitive reactance. So how you are defining capacitive reactance? How you define capacitive reactance? How you are defining inductive reactance? Tell me. Inductive reactance,
Opposition
opposition
to the flow of
to the flow of current by an inductor. Capacitive reactance is what? Opposition to the flow of current by capacitor. Simple term में define करना. Inductive reactance is the opposition to the flow of current by an inductor. Capacitive reactance is opposition to the flow of current by a capacitor. Okay, so here I am writing opposition to the flow of current by a capacitor is called as capacitive reactance. Okay, got it, all of you?
Yes, ma'am.
So now we will move to, yes, so I have drawn the graph at as is x increases, f decreases, as x decreases, f increases. Clear to all of you? Written, all of you?
Yes, ma'am.
Okay, so here I have forgot to tell you one thing here, just where you have written, tell me, write that one. So here I have got, in this case, I have got V equal to how much? Vm sine omega t. What was the value of I? Tell me. I, what you have got? I is equal to how much? Tell me. I is, I is equal to CVm omega. What you have got? CVm omega sine how much?
T plus
Omega t plus
minus
pi by 2. So this is equal to how much? This is CVm into omega is what? CVm into omega is equal to I maximum, right? Sine omega t plus pi by 2. So from these two equation, what you have concluding, tell me? What you are concluding from these two equation? This is my voltage graph. How will be the current graph? Tell me.
Ma'am, before pi by 2 before.
Very good. Very good.
before origin.
Very good. Before origin it will start. So this is your pi by 2. So here the waveform of the current will start. Am I clear to all of you, or anybody having doubt? Tell me. No doubt. अरे yes बोलो, नहीं तो no बोलो.
No, ma'am, no doubt.
No doubt, no.
So this is the voltage graph. Okay, very good. So this is the current graph. So what you are concluding between voltage and current in a pure capacitor with a with AC supply? So here I am writing a note. So what you are getting? Tell me. You are getting V is equal to how much? Vm sine omega t, and current what you are getting? I is equal to Im sine omega t plus pi by 2. So what you are getting a conclusion? Tell me. In an AC circuit with pure capacitance only, in an AC circuit with pure capacitance only, the applied voltage, what? Tell me.
Lags.
Lags behind with
With
K pi by 2.
applied voltage lags applied current, by an angle of how much degree?
Pi by 2.
Angle of pi by 2 radians, or how much degree? Or 90. Okay,
90.
very good. Clear to all of you?
मैम थोड़ा वेट कीजिए, लिख रहे हैं.
कहाँ?
Note.
In an AC circuit with pure capacitance only, the applied voltage lags applied current, or also you write down another. Applied voltage lags applied current, or the applied current क्या हो रहा है? Leads the applied voltage by an angle of how much? Pi by 2 radians or 90 degree. Got it, all of you?
मैं वो थोड़ा ऊपर वाला ग्राफ दिखाएगा।
This one?
यस मैम, थोड़ा सा।
Then only power I will complete. Written?
यस मैम, डन। यस मैम।
Now, last one is your instantaneous power. Instantaneous power is what? Instantaneous power, P will be equal to how much? P is equal to V into I. So this is equal to how much? Vm sin omega t multiplied with how much? Im sin omega t plus or minus? Plus pi by 2. Okay. So this is equal to Vm Im sin omega t. Sin omega t plus pi by 2 is cos omega t. So this is equal to Vm Im divided by 2 sin 2 omega t. Okay. 2 sin omega t into cos omega t is your sin 2 omega t. So this one is your divided by 2. So if you'll find out the average value, so what I have to take? I have to integrate it over one complete cycle. This is equal to Vm Im divided by 2 sin 2 omega t. Okay, so if you'll find out the average value, what you will get, tell me? If we'll find out the average value, we'll take it as 0. Very good. So here, you can write down in the note as the average power consumed by a what? Which circuit I have taken?
Capacitor.
By a pure capacitor tail, huh? Because I have not taken resistor here. Only capacitor means resistance will be included. That we will discuss in the next class. Average power consumed by pure capacitor is what?
0.
Okay, these are star note, everything. These are very important point. So in the waveform, just in the same waveform which I have drawn it earlier. Okay, I will not move the board. I will do it here only. You can do it there. This is the voltage waveform, and current waveform starts what? Starts earlier. Okay, this is the current waveform. No need to do it again. You have the graph, you have drawn it in the same, you draw it in the pencil. It would be better. So how do you find out the average power? Average power, here you see between this point to this point, your voltage is, this one is what? Voltage. This one is current. So one is positive, one is negative. So power will be negative. Somebody is asking something?
No, ma'am.
Okay. So from this point to this point, both are positive? Yes or no? So power will be what? Positive.
Positive.
Okay. From this point to this point, your voltage is positive, current is negative. So power will be negative. Okay. From this point to this point, both are negative. So power will be positive. Am I clear? So now somebody will tell you what is the average of this one. Look at here. Average will be equal to. Here to all of you.
Yes, ma'am.
Yes, ma'am. Clear.
So what to this? So you have got 4 conclusion. First one is, in an AC circuit with pure inductor only, the voltage leads or current lags by an angle of exactly 90 degree or pi by 2 radians, and average power consumption is 0 for an AC circuit with inductor only. Similarly, in case of pure capacitor only, the voltage lags the current or the current leads the voltage by an angle of exactly pi by 2 radians or 90 degree, and here also the average consumption of power is 0. So that is why here you see the average power consumed by pure capacitor or pure inductor is 0. That is why these two are, the inductor and capacitors are called as energy storage element. Okay, here you see in one, this is 1 quarter cycle. Okay, next class I will discuss 1 quarter cycle. The power is moving from load to source. In the next quarter cycle, the capacitor is giving back that power which it had taken in the first quarter cycle. It is supplying back that power to the load again in the next quarter cycle. Understood? That I will discuss later on. So here you see positive, negative means in one case the power is flowing from source to load. Second case negative means the power is flowing back from the load to the source, from the capacitor to the source. That means it is not at all consuming the power. It is consuming the power, it is keeping, then in the next quarter cycle it is again supplying back. Understood? All of you? Got it? All of you?
Yes, ma'am. Got it, ma'am.
somebody was asking something.
नेक्स्ट क्लास में फिर से एक बार रिपीट कर
हाँ हाँ नेक्स्ट क्लास में रिपीट कर दूंगी ठीक है चलो दोज हु हैव गिवन द अटेंडेंस यू कैन लीव दोज हु हैव नॉट गिवन
अटेंडेंस मैम जिन
हाँ,
लोग
ma'am.
हाँ दोज हु हैव गिवन द अटेंडेंस यू कैन लीव दोज हु हैव नॉट गिवन
ओके थैंक यू मैम
थैंक यू
हाँ
मैम
हाँ थैंक यू चलो समृद्धि